Hi everyone! Yesterday we focused on simple events, and today we're going to move onward and start focusing on compound events. So if you flip the page, we'll start with an activity. Okay. This says Amy wants to pack enough items to create 6 different outfits. She packs 1 jacket, 3 shirts, and 2 pairs of jeans. Can Amy create 6 different outfits from her clothing? Okay, what I want you to do is this chart has been started for you and it's up to you to finish. Okay, so there's a blank here, here, and 2 down here. Pause the video, see what you can do, and come back. Okay, now that you've tried this, okay, we should be able to finish it together. Okay, down here, if she starts with a jacket and shirt number 2, okay, she also needs jeans number 2. Okay, and then we have jacket, shirt 3, jeans 1, jacket, shirt 3 with jeans 2. So hopefully you're able to get through that chart. Okay, and what we have here says the table is an example of an organized list. Okay, you systematically went through all of her options. Okay, is there a different way that we might have been able to figure out all of her possible choices? Okay, and the only thing I could really think of is possibly some type of visual or graphic organizer. Okay, and that's where we're going to focus some of our attention today. Okay, now question 3 says to describe another situation for which you might want to list all of the possible outcomes. Okay, so other than picking out outfits, okay, when in life might you want to make a list of all of your possible outcomes, your possible choices? Okay, and we'll start with that as kind of your warm up tomorrow, so make sure you answer that. Now on the next page, we're going to dive in. Okay, a compound event is when you have 2 or more events. Okay, so we focused on a simple event, okay, 1 event before, and now we're gonna mix it up a bit. So example 1 says 3 students, Adrian, Carlos, and Greg, were chosen to represent Ms. Cook's class in a school assembly. All 3 of them need to sit in a row. Use a list to find the sample space for different ways they can sit in a row. Okay, so this time we're going to make a list similar to our activity on the last page. Okay, we're going to use A for Adrian, C for Carlos, G for Greg. Pretty straightforward. Okay, so if you're sitting in a row, Adrian could sit first with Carlos second and Greg third. That's one option. Or we could have A, G, C. Okay. Or C, A, G, C, G, A, G, A, C, or G, C, A. And I'm pretty sure that's all of our possible choices. Okay, now what's nice is when you only have 3 students, the list is not too big, okay, and it really works out quite nicely. But when you start having multiple options with several choices each, your sample space gets quite large. Okay, this right here is your sample space. Okay, it's all your possible choices, and for this one there's only 6 possible outcomes, which is nice. But sometimes we could have, 20, 30, 40, okay? And that's when we want to opt towards using a tree diagram, okay, which is a diagram that has branches. Okay, that's what we call a tree diagram, and it's used to identify the sample space. Okay, I'm going to skip this here, and if you could please flip the page, we'll do our first example together. Okay, so number 1 says a car can be purchased in blue, silver, red, or purple. Okay, so we have 4 different colors. It also comes as a convertible or hardtop. Use a table or tree diagram to find the sample space. Okay, and I'm actually going to have us focus on a tree for the different styles in which the car can be purchased. Okay, so there's 2 decisions that need to be made. Okay, the color and the style. Okay, and that means we're going to have 2 sets of branches. Okay, so I always like to start at a home base. Okay, the first decision that gets made is the color, and there's 4 possibilities, so I'm going to make 4 branches. Okay, Okay, B for blue, S for silver, R for red, P for purple. Okay, and then once we make that decision, we have to decide if we want a convertible or a hardtop. Okay, so from our original branches, we're going to make second choice branches. Okay, hardtop, convertible, hardtop, convertible, hardtop, convertible, hardtop, convertible. And that's the part that's kind of funky. Okay, because we don't know what path we're taking, we have to account for all possibilities. Okay, and then this is the hard part. We need to read the branches. Okay, I recommend using a highlighter as you go, and we'll list our sample space. Okay, so you could choose a blue car with a hardtop. Okay, write that down. Okay, so off to the side. Okay, we'll do blue hardtop or blue convertible. See how I'm just reading the branches? You could have silver hardtop or silver convertible. Red hardtop or red convertible. Purple hardtop or purple convertible. And because we read every branch, we know that we have everything in our sample space, and then we just count it up. 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Okay? I want you to try number 2 on your own, and we'll go over it tomorrow. Okay, now that you've had a chance to try number 2, we'll do another one together. And this one's just ever so slightly different. Okay, this says, suppose you toss a quarter, a dime, and a nickel. Find the sample space. What is the probability of getting 3 tails? Okay, so not only do we want to know our sample space, but then we have to take it a step further. Okay, so we are flipping 3 coins. Okay, we'll start with the quarter. When you flip your quarter, you can get heads or tails. Next, we'll flip the dime. And for the dime, you can get heads or tails, heads or tails. Okay, you have to have a branch off of each of the original. Okay, next we'll do a nickel. Heads or tails, heads or tails, heads or tails, heads or tails. Okay, and then we're gonna read our branches and make our sample space. So you could get heads, then heads, then heads. Okay, and I'm just going to abbreviate H, 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 T. You could get H, T, H, or H, T, T. Okay, so we finished our one original branch. Now we'll swoop over here. You could get tails, then heads, then heads. Tails, heads, tails. Tails, tails, heads. Or tails, tails, tails. Okay, so how many possible outcomes are there? Okay, there's 8 possible outcomes. And then of those 8, how many, or what is the probability, what are the chances of getting 3 tails? Okay, well, there's only one of those out of a possible 8. Okay, so we made our tree, we listed our sample space, and then we calculated a probability. These are time consuming. You have to take it slow and steady, and you have to be careful. Okay? I want you to try number 4 on your own. Okay, we'll go over it tomorrow. Flip the page when you're all set. The last thing I want to show you is called the fundamental counting principle. Okay? This is a method that uses multiplication to find the number of outcomes. Okay, and the key here is it's the number of outcomes. It doesn't tell you what your outcomes are, just how many you should be getting. Okay, so we look here, it says find the total number of outcomes when a coin is tossed and a die is rolled. Okay, well, a coin has 2 possible outcomes, right? You could get heads or tails. Okay, and then a die has 6 possible outcomes. Okay. In order to figure out your total number of outcomes, you multiply the 2 together. Okay, so we would do 6 times 2, and we would see that there are 12 different outcomes. And now notice it doesn't tell you what those outcomes are, it just tells you how many you should have. This can be helpful though when you're making a tree diagram because it tells you how many outcomes you should have in your sample space. Okay, so we're going to check it now and prove that it works. Okay, so your coin, okay, you could get heads or tails. Okay, and then when you roll a die, you could get 6 different outcomes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so you could get heads, then roll a 1, heads, roll a 2, head 3, H4, H5, H6, or you could get tails, then a 1, T2, T3, T4, T5, T6. How many possible outcomes are there? 6 here, 6 here, 12 different outcomes. Okay, on the next page, you have one last practice. Remember, I'm checking all 3 of those tomorrow. Good luck.